All right. I think I think the stream started. Let me check. Let me check. Uh, yeah. Okay, yeah, it is. Yeah. Okay, yeah, it is. Yeah. Okay. Okay, yeah, it is. Okay, god damn it. Alright, let's start. So, yesterday we were right here. Okay. So, welcome back. Yeah, I'm sorry. I'll introduce again. Today is Jan 2nd. Yeah, today is Jan 2nd. And we will be doing. Let me tell you the agenda for today. So, we will be doing one is signals. First of all, should be resolving yesterday's yesterday's streams problems. That's one. And second will be signal and signal handling in C. The third will be circular Q in C. So yeah, so these will be hopefully we will complete these things today. So yesterday, if you remember, we ran into some problems. Peter creates TID null, why null? So okay, let's first run it again and see what's the problem here, right? Oh, God damn it. Right. So okay, sorry. Okay, so we're in John 1 and let's just first compare this again. If you remember, let me just give you a reminder that we were implementing the TCP concurrent server using pthreads, and I think we ran into um, segmentation fault. So let's just resolve that. So I do not know why segmentation fault is occurring, but segue. So I'm not really. I am not really good at this. Let us explore together. Okay, so let's just first explore how why a segmentation fault occurs. So let me Google that first. So okay, there's a Medium article here. Hmm, okay, so let's just read this. It is a critical error that occurs when a program attempts to access a memory location that is not allowed to access. Yeah, okay, I kind of know that. It is a combination. C program can be frustrating to debug. In this article, we will explore and discuss the can identify and resolve them. So there's a stack, there's a heap, here's utilized data, uninitialized data. So I'm sorry, initialized data and text, low address and high address. In C program, memory is divided into two distinct regions: the stack and the heap. The stack is the region memory that is used to store local variables, function parameters, and return addresses. Store local variables, function parameters, and return address. The heap is a region memory that is used to allocate memory dynamically using functions like malloc, calloc. So the heap is a region that is used to allocate memory dynamically using functions like malloc and calloc. Okay, that's cool. So stack is basically for the local variables, function parameters, and return addresses. Memory segmentation is the process of dividing a program's memory into these two regions. When a program is executed, the operating system. Uh, I'll be right back. 1 second. Hello, can you hear me? Oh, okay. Yeah. Um. Yeah. Okay. I will be right back. Alright. Okay, it's okay. Let me just. It's okay. So I'll be right here. I'll go. Why segmentation occurs? God damn it. 1 second, dog. 1 second. 1 second. I'm back. I'm back. I'm back. I'm back. Is that this? Too much sound is coming. Fuck, man. Alright. Okay. Let's just do it. Let's just get on with it. The heap is a region memory that is used to allocate memory dynamically using functions like malloc and calloc. Memory segmentation is the process of dividing a program's memory into these two regions. When a program is executed, it's the process of dividing a program's memory into these two regions. When a program is executed, the operating system sets aside a certain amount of memory for the program stack and heap. Okay, the stack grows down to the memory and each function will call. Oh, 1 second. I'll just be back. 1 second. Alright, um, back. There's some issues here that that's why I'm going offline and going online. There's some issues in the house, but okay. The stack grows down in memory, and each function call creates a new stack frame that is added to the top of the stack. When a function returns, its stack frame is removed from the top of the stack. This makes the stack a last in, first out. And obviously, a stack grows down in memory. Each function call creates a new stack frame that is added to the top of the stack. So when a function returns, its stack frame is removed from the top of the stack. So it's kind of like, uh, I don't know. It's kind of like this, right? So a stack is like, where's the pen? A stack is kind of like this. And yes, across down memory, a function calls creates a new stack that is added to the top of the stack. So whenever the function f1 comes here, f1, f2, I think the stack. Oh my god, I don't have a mouse. That's why it's becoming a little hard for me to draw. Damn it. Okay. Yeah, a little hard for me to draw, but yeah, you get the idea, right? So f3 stack stack goes down in memory, and each function call creates a new stack that's added to the top of the stack. So whenever new function comes, it's added here. New function. Yes. Fuck. Oh my god, this is so hard. Drawing with a drawing with the trackpad is so hard, man. I don't know. Okay, so when a function returns, the stack frame is removed from double stack. So stack last in, first out. So whatever is on double stack, it goes out, and whatever new function comes in, it also goes on double stack. Huh. Okay. Goes out for the memory, and memory allocated on the heap must be explicitly deallocated using functions like free. Unlike the stack, the heap does not have a specific order in which memory is allocated or deallocated. What memory is allocated on the heap must be explicitly deallocated using functions like free. Unlike the stack, the heap does not have a specific order in which memory is allocated or deallocated. Understand memory segment is important for C programs because it allows them to manage memory more effectively. A memory allocated in the heap must be explicitly deallocated using functions like free. So yeah, okay, okay, okay. A segment occurs when a program tries to access a memory location outside of its allocated memory space. Okay, so when a program tries to access memory location outside of its allocated memory space, this can happen due to dereferencing a null pointer. Dereferencing a null pointer is a common cause that segment is called. It is used to ensure that pointers are properly initialized before accessing them. A null pointer is a pointer that has the value of null. It is used to indicate that a pointer does not point to any valid memory location. When a null pointer is dereferenced, the program is trying to access a memory location that does not exist. This can cause segmentation fault. I think, well, I think it's just better to have a text that basically what we're doing right now. I think that's better for new users to come in and see that what is happening. So let's just let me just let me just oh my god, I'm so bad at this. Okay, that's much better. So the first is dereferencing null pointer. So when a pointer basically, yeah, so it's a null pointer and you're assigning it to basically you're dereferencing here. So basically, that's invalid. When an input is defined, the program is trying to access memory location that does not exist. This causes segmentation fault. Okay. How depends memory access? Accessing memory beyond the allocated boundaries of an array can lead to a seg fault. It is essential to validate array indices to ensure that they stay within the valid range. So, accessing memory beyond the allocated boundaries of an array. So, okay, that's cool. That's understood. Accessing an uninitialized freed memory block, it is also an undefined behavior because when pointers use to access memory that has not been initialized, that has been previously freed. Okay. Accessing uninitialized memory here, print a file before initialization, undefined behavior. Oh, well, yeah, because we have not defined, well, we have not initialized any part of the memory to the pointer. That's why a second fault occurs. That's cool. Now look at this. You're freeing the pointer address or the freeing the memory that is associated with the pointer, and then you're freeing it, and then you're trying to access it here. So that is also a seg fault. Okay, stack overflow. If a program's call stack grows too large due to a large number of nested function calls or requests, it can cause a stack overflow. Alright, so too many function calls in the stack can also cause a segmentation fault. Buffer overflows right beyond the bounds of an algorithm memory can lead to a segmentation fault in C. Okay, buffer potential buffer overflows str cpy. Okay, debug seg faults. The program typically crashes and produces a code dump of an error message. The error message might include information about the memory address causing the fault and the specific line of code or where the fault occurred. Tools are debuggers, and so okay. I don't think we have any information about. I think this is the what is this? This is the PID. Is it? I don't know. Is it the PID? Damn it. So can also assist in identifying the cause of segment fault. Initialize pointers always need to null before using them. So okay. Ensure proper allocation deallocation memory using functions like malloc free, calloc, and dealloc. About checking. Okay. Thorough testing. So let's just check our code. Let's just try to see what's happening here. So conf d, we are doing that. Obviously here is the pointer, so we need to first look about the pointers if we're doing or accessing it in any wrong way. So okay. Hmm. So void star p thread self. Is it really needed though? What is p thread self? Uh, return. I think it returns thread ID. It returns p thread t type. So why are we doing that? I don't think that's needed. Let's just do that. Okay, we have a warning, but okay, but let's just see if we're getting any segment. Oh, we are still getting a seg fault. Okay, that is. I mean, that's alright. So you should not dereference a null pointer. But he says that always initialize pointers to null before using them. How to use null pointer properly in C without seg faults. So always use pointers null if they are not assigned to a valid memory. This ensures that if you accidentally use them before they are properly set, so if they are not assigned to a valid memory location, okay, this ensures that if you accidentally use them before they're properly set, you can detect that they are null. Check for null before dereferencing. Or check whether it is null. Different null button will cause a seg fault. Using null for function arguments. If you're passing a pointer to a function and the pointer might be null, you should check for null inside the function before dereferencing. Okay. Alright, I think this is the problem. But I'm not really understood this point though. A pointer initializes null. If you initialize it to null and then access it and then later on dereference it obviously, then what's the point? I mean, please explain more. When initial is pointed to null, you're assigning it to it a special value that indicates that it doesn't point to any valid memory location yet. Usage of the pointer is not yet initialized any real data is important because if you use a pointer that has not been initialized, it might contain a garbage value, random memory access, which can cause the program to crash, behave unpredictably by initializing the pointer to null. You can later check if the pointer is still null before using it, which helps prevent mistakes like dereferencing uninitialized or invalid pointer. That's cool. Okay. So why is it important though? Prevent dereferencing while uninitialized pointer. Point is not it can contain random memory address garbage value, and if you try to dereference it, your program will most likely crash with a segmentation fault. This is because you're trying to access memory that doesn't belong to your program. So I ensure the pointer null. You ensure that it doesn't point to random memory and continue to check whether it has been assigned a valid address. Okay. Hmm. Alright. Okay. Helps in detecting pointer usage error earliest. Pointer safety instruction null. Safe to reference since pointer is not null. Okay. Else pointer is null cannot be referenced. I think that's the problem here. So let's just do that. Okay. So let's just first check that arg if arg is not equal to null. Is that? Yeah. Okay. Then you can use it. Well, then you can use it. If it is null though, or let's just do this. I'm sorry, what am I doing? Okay, let's just do, if it is null though, then let's just do p error. Okay, let's just do that. Yep. Okay, let's do that. Okay, at least this is not null though. So the argument is being passed. Where's it? The argument, yeah, here. The argument is being passed. So void pointer to arg. So here is also void star in period t, casting the pointer to an integer, and void pointer corner t. So it's mostly the pointers that we have uh, we gotta take care of. So here car I think there's no problem around here because obviously it's not null. If it will never be null because there should be a file name here, so for arg there's no problem for that. And struct sock at pointer, I don't think that's a problem either because we have done this, and also yeah, we have defined it here, so we have actually assigned an address in this line, and here. Okay, yeah, that's cool. Okay, the only thing is void pointer int pdt. Let's just remove this. Let's just remove this. Let's see what happens. I don't know what happens, but yeah, let's see. Okay, okay, that's an error. We need that, right? So because it's a void star argument, and we're not passing in a void pointer here, so we need to do that. Okay, sorry. Then what is the problem? Let's see. What's happening? What is the problem, man? What is the problem here? Well, handle client, if you think about it, it is what it is. Okay, that's cool. The second argument is constant p3 attribute. It's none. That's cool. Two, void star routine void star. Do we need to find? Do we need to do that? I mean, well, it's just a pointer. So, and this is also a function, and we're passing in the function of this type. Do we do that? No. Do we do this? Still segmentation fault. Not too sure. Let's just see if GDP is there. I do not know how to use GDP. I don't think GDP is available. Is GDP available on Mac? One. No, GDP does not run natively. I think there's a debugger. I think there's a debugger here. Oh my god. Not a debug. Okay. I've never used this, but let's see. Okay. No. Let's see. I'll just do default and see if I can do it here. That second. Dude, what's the deal here? Is that debug? Yeah, okay. Clang build and debug after file. Oh, good. GCC. I'm comfortable with GCC. Let's see. Build finished with warnings. What's happening? Terminal will be used by us. Please press any key to close it. I have no idea how to use this. What the fuck is this? How do you even use this though? It's just a server port number. I do not know. Let's do ChatGPT. I am Right, is a type that can hold pointer values. It isn't directly guaranteed to work in all when used to represent integer file description in a pointer context. So the word pointer in the correct version is this. So what directly to thread function via p3 create. Okay, how are you doing this? By casting it into int ptrt and back. While int ptrt is designed to hold pointer values as integers, this cast may not work properly across different architectures. In your code, casting it into, yeah, I mean, pointer values as integers. This can be now probably across different. In your code, you're passing in the socket descriptor confd as a void star int ptrt confd to a thread. However, confd is an int, and int ptrt is a type that can hold pointer values. It isn't directly going to work in all situations. When you use the present integer file descriptor pointer context, you should instead pass confd as a void star by directly casting it to void star in the p3 create argument. Uh, Dude, what did he even change though? Trying to cast the. Should use this cast safely? What do you mean? Use this cast safe? That's what I have been doing, right? What do you change? Oh my god. Did I do two? Oh my god. Damn it, dude. Fuck, man. Shit. I did two here, dude. I used argv too. Damn it. Oh my god. Now it should work. Did I do the same thing for client too? No, I was. Nah. Okay, that's cool. But yeah, that is also the changes that ChatGPT also suggested is also pretty good. Um, which is what I've tried actually. This is cool, right? I mean, that's what it suggested too. So yeah, I mean, okay, that's pretty cool. But yeah, in pediatric community, that's what I have done too. So and port validation. That's I think that is the problem. And warning generated, but I don't care about the warning. Oh my god, yes. Yes, I think, yeah, that's what it's the debugger has also been telling me all this time. Such a. I'm such an idiot, bro. Damn it. That's the like that's the minutest thing, and I have spent like 45 minutes on it. The most minute thing, right? Okay, let's see. Okay, what is that? Hmm. Undefined error. I need P21 is basically you are you're changing the presentation on byte order to a network byte order basically. I, that is the correct thing, but let's just see if what shit what is the man page for INP2 and int if and is it okay? I don't think it's the if init here. Yeah, I mean it is argv1, which is the pointer to the source, which should be that, right? 012. So RIB. So that is cool. So where synod, the destination, the address of, so where is synod? I think yeah, I mean that's cool. What is the deal? It said it said what did it say? It said int af. I mean int af is basically it is what it is, right? It is what. Hmm. In domain, is it the domain though? Address family, the same thing, right? It's not. It's not this though. Is it this? I don't think. I don't think it is that. Not supported by protocol family. Exactly. AF INET is the correct thing. Undefined error 0. Okay, one second. What does the return value of INET P2 say? What does the return value 0 say? Converts this percentage form an adder, that is the print performance held in character setting, to a network format usually is structured in adder or some other internal variable in network variable. It returns one if the address was valid for the specific or zero if the address is not parsable in the specified address family. It's not parsable in the specified address family. What does that mean? Uh, it's not parsable. Just passing in. Is it two? Oh my god. Same mistake, dude. Same arguments mistake. It should be the address first, port next. Oh, wow, let's get it. Let's go connect it. What's up? What's up, server? That's it. Very cool. Oh yeah, that's insane. That's pretty good. Okay, client disconnected. That's very nice. That's very nice. We've done it. That's pretty cool. So I don't think we've done anything in client. It's just the same as. I mean, I'm just revising what I've done yesterday. But yeah, but it's just that we have we use write function, read function, and basically to write to the socket. That's pretty cool. And then read, and then we also null terminated the string and just printing out the a code from server, and we're closing the socket and returning. Server side is where the meat of the matter is. Basically, accepted quantity less than zero, prerror accept printf printing new thread for each client. So here is the meat basically. So after using listen, entered basically an infinite loop for keep on accepting. Okay, let's test if multiple clients are there. Sorry, I did not try that. If that is working. Yep. Let's see. That's cool. But is it also working? Yep. Two different threads. What's up from client 1? So it echoed what's up from client 2. It also echoed. That's pretty cool. If I type exit, client disconnected, this does not exit because it's just one. It keeps on running because that's what we've done. We've just used while infinite while loop, so it just keeps on running. And then okay, that's pretty good. I think it's working. That's nice. That's nice. So the thing I think what you've done is basically avoids pthread create and tid. The tid is the pthread tid, right? The thread id, and we're not using array because um, well, once you accept once basically a client comes in, for each client there's you create a thread basically. That is what it is, right? See, I'll be honest with you, I just revised the code before the stream and I wrote this yesterday, but I'm not really sure why in this code um how is it handling like two clients, multiple clients, because the p3 tid we have not used an array here. We've just used we just used this, right? We just used p3 tid. Should we use an array for multiple clients? Why are we how not using an array of p threads for handling each client? What are we actually doing here to handle multiple clients? Okay, that's my question. Let's see. In your current server, you're handling multiple clients using pthread based concurrency by creating a new thread for each incoming. The reason you're not using an array for handling is primarily a matter of design and resource management. Thread plural for each incoming client, new thread is created using the pthread create. This runs the handle client function which processes the communication with that specific client. Just after creating a set, you immediately detach it using pthread detach tid. Data are independent on the resource like memory. You don't know in advance how many threads you will find. The Morgan's effect, so maintaining an array of threads would not be practical. Instead, you can create and data lines connect. Mm-hmm. So basically, you're creating a new thread for each client. Each time a client connects via accept, so after it connects, actually you create a new thread to handle that client using pthread create. This function and client is the interpret for the new thread. As passed an argument to the function. And in the client is hand client function, each thread is created on hand client where with the client reading and reading loop. Once the client disconnects, the thread exits and the resource by the thread are automatically cleaned up because the thread was detached. Hmm. Called right after creating the pthread detached is called right after creating the thread. This means that once the thread finishes executing, it will automatically cleaned up by system. Okay. Each client is handled in separate thread concurrently. This allows user. Okay, we're not using pthread join actually. That's cool. That's cool. So pthread ttid definition that we did in the main loop. Uh, will it have two values if the server is connected to two clients? Sorry, I might be dumb, but yeah. Okay, and taken multiple values. It's defined once as singular, but each incarnate and each thread creates its own unique p theory during the call to p create. Okay, so overwritten. So okay, that's good because theory is being reused to store the ID needed. The material always holds the most recent thread ID because it is a single. So okay, so it overrides that. And it's the first one creating a thread, and TID will hold the ID of that thread. The server handles the second client by creating another thread, and TID will now hold the ID of the second thread as you continue to have more clients. Most recently created thread. Since the threads are detached via pthread detached TID, the main thread doesn't need to track or join the threads later. The operating system will clean up. Okay, the pthread once it finishes. Therefore, the server does not need to maintain a list or because each thread cleans up after itself when it finishes execution. That's cool. Nice. Could store, yes, if you wanted to keep track of each thread separately, for example, let a pthread join them or log their progress, you could create a dynamic list of pthread variables. However, in the current design, you don't need to store these values as just will automatically clean up data threads. Okay, that's cool. Okay. Yeah, so I think pthread join it's just that after basically Pedro join waits for all the threads to complete, right? I think suppose around wait for thread German exactly. So since we are directly using pthread detach in the code itself for each thread, Um, there's no need for Peter, John, and an array specifically. That's pretty cool. So, okay, I'm just gonna log it here because, yeah, I'm just gonna log it here. That's cool. That's pretty cool. I'm just gonna change it to Markdown for better readability. Dude, what am I doing? Yep, okay, true. That's cool, yep. Yep. Alright, that is cool. So, one thing. This is done. What am I doing, dude? That is done. Signal and signal handling C. We finally come on to signal and signal handling in C. Okay. I think for that, yo, how much is it? So 1 hour 10 minutes. ETU Cyber. ETU Cyber. How many people are watching? I'm not realized the people watching. Hmm. How many are watching now? Did I not? Damn it! Did I not live chat? I'm so bad at this, dude. Why? 1 second. Let me just check if I'm not really leaking anything. Okay, I think I'm not leaking anything. Oh, damn it. Why do I need to enter my. Oh, damn it. Why do I need to Hello. Oh, well. Hello. Oh, oh, oh. Oh, oh. Okay. All right. Somebody. Yeah. Okay. Actually, somebody commented. I'm very happy actually. I just needed a second to uh see if it is a real account because wow. Well, you are my first viewer, I think, dude. ATO Cyber, you are my first viewer. That's crazy. That's crazy. How do you even reply? Oh my god. Thank you. Well, thank you. Thank you. Thank you. Thank you. Alright. Yep. So I just got a little distracted, but it's always. I'm acting as if I always have yours, but well, yeah, you are my first viewer. That's pretty cool, man. Yeah, so okay, now the thing we need to do is signal and signal handling and see. Alright, I think let's do that. Yep, let's do signal and signal handling in C. Hmm. Uh, yep, so just so that it's. Uh, Alright, yeah, so signal and signal handling, I think, let's see. Well, okay, to answer the question, somebody told me to use NeoVim. Yeah, yeah, NeoVim, but I have limited time. I mean, not really. I think I have time, but it's just that the learning curve for NeoVim is kind of hard. I think so. I'm just sticking to VS Code as of now. But if I had time, I will switch over to NeoVim because I think that's what all the programmers have been using lately. I'm a Primogen viewer, and yeah, So obviously I know how powerful NeoVim is. So I'll try to you know learn NeoVim. I will try to learn NeoVim for the next stream, at least for the next stream. I think probably in the next stream we can do that. But yeah, so we have two more things to do: signal and signal handling. So let's do that, right? What do we do first? Do we do circular queue? Do we do circular queue in C or signal handling in C? Because signal handling, well, to be sure. Yep, okay. So it's in here, I think. So if you think about signal, let me take out the textbook and see. So what am I doing? So signal handling in C. So signals in C. Oh, this all of this man function. Let's just read the man page for signals as of now. Let's just read the signal man page. So void pointer signal int sig void return value pointer to a function that takes an integer as the argument. Damn it, why is this so difficult to read though? Let's just first import the statements. What else is there? I think, yeah, I think that's it. Oh, let's just do this too. I have realized that the title of the stream is wrong though. Probably change that, but yeah, it should be 002, but it's 1. Why do you even change that though? I think I'm actually tired, so I'll be back probably in 30 minutes for doing another stream, fixing a little bit of issues in the stream. So I will be back after I fix that, and I'll have my dinner and again stream again. So